Welcome to the lair of the Batty Boffin.
Hi there Batty fans, it's time for a little bit of GCSE higher level maths revision. We're doing exam questions with Bathilda the Batty cat. Now today she's in her car and she's about to drive over the bridge because quite frankly she doesn't want to fall down this ravine and be eaten by the cat-eating crocodiles down there. And this bridge, as it happens, is a very mathematical bridge. It's formed by a horizontal line and part of the arc of a circle. Now, this circle, if you continued the whole of it, would have a centre at O and a radius of 100 metres. The centre point of the bridge, the highest point, is 15 metres above the roadway. So I have two questions for you. Number one, how long is the bridge on the roadway? And for part B, how long is the beam over the top? Okay, so you pause the video and have a look at those and then we'll go through them together. Right, here we go. The first part's not too difficult. We've got our 100 metres here for the radius. That is also the distance from O up to the highest point, it being another radius. If that bit is 15, then what we can do is drop a vertical down here. That is a right angle. Because it's an isosceles triangle, of course we're chopping it neatly in half. If that's 100 and that bit's 15, it means that that bit is 85. And now we've got a simple bit of Pythagoras. So we've got the 100, we've got the 85, and we want to find, we're going to just find half the length of the bridge and then double it, of course. So we're going to do 100 squared. I'm just going to swap to a pen that actually writes. (100 squared minus 85 squared equals, I'm going to call that question mark squared. Grab my trusty pink calculator. You don't have to do it with pink, grey and black ones work just as well. We're going to do 100 squared minus 85 squared equals that, square root the answer, and we get 52.67 for that. Actually it's 6.8, isn't it? Don't of course forget to double it. So times by 2 to get the full width of the bridge. And the full width of the bridge, D for the distance along the bridge, equals 105.4 metres. Okay, so that bit not too difficult there. Part B, a little more, so I'm just going to do one of those things where we go black. I'm going to wipe out the board and we'll do part B in a minute. Right, now for working out this curved part, that is the arc of a circle. In order to do that, we're going to need to work out the full circumference of the circle, which is dead easy because we've got the radius, and then we're going to need what part of that circle we've got. In order to know what fraction of the circle we've got, we need to know the angle down here. Again, I'm just going to work out half of it and then we'll double it in a minute. I'm going to call that theta. You can call it A or X or something like that if you want. And again, we're going to use this right-angled triangle. I've got the hypotenuse and I've got the adjacent. I mean, I could use the opposite as well, but I'm going to use that adjacent there. We know from our triangles that we've got soh, kah, and toa, SOHCAHTOA. And given that we have got the adjacent and the hypotenuse, we're going to use cosine. So that tells us that the cosine of the angle, theta, is equal to the adjacent, which is 85 over 100. Okay? If you're not sure how to do this, there are other Batty Boffin videos that will go through it a bit more slowly, but I'm just zipping through it right now. So we're going to do 85 divided by 100. That is the cosine of the angle. So we're going to do cos to the minus 1, or inverse cos, depending on your calculator. Cos to the minus 1 of the answer equals, and we get an angle for theta as being 31.79 degrees to 2dp. Okay, which is pretty good. Don't forget to double it, okay, because we're going to need the whole thing over there. So that means that that whole angle there is equal to 63.58. 63.58 degrees. Okay, so we've got the angle, we know what part of the circle we've got. So from here, actually I can fit it down here, can't I? The whole of the circumference of a circle is equal to pi times the diameter, or 2 pi times the radius, so 2 times pi times 100. And we only want a fraction of it, so we want 63.58 out of 360 of that. So 2 pi r will get us the full circumference, and then that's the fraction of it that we want. So I've got my fraction on there. I'm going to do the divided by, whoops, not 6, 360. Okay, I've got that bit there. Multiplied by 100 equals that. Multiplied by 2 equals that. Multiplied by pi equals that. And I get an answer eventually of 110 and a bit. So that means that my arc length up there is 110 point, well actually to 1 dp, it's 96, so that's 111.0 to 1 dp. Okay, which looks perfectly reasonable if we've got 100 and whatever it is, 104 along the bottom, 111 over the top. Okay, hope you got that. There are 1 or 2 other methods as well. You could use sine or tan or something like that, but as long as you end up with 110.0 to 1 dp, that's it done. Okay, hope you had fun with that. I'll see you next time, Batty fans.